Okay, I'll go live, start the webinar now. Second. Okay. Good morning, everyone. Welcome to today's webinar. My name is Kabir, and I'm with Bat Liver Research Group. I will be host for today's session. We got two amazing speakers joining us today, and they will be talking about swath grazing strategies for livestock producers. Before we get started, I'd like to take a moment to thank all the counties for their support and funds. Because of their support, we are able to offer a webinar like these and bring valuable information out to the producers. Just a couple of quick housekeeping items. If you have any questions during the presentation, hold them until the very end of the session. We will have a 15-minute Q&A. If something urgent comes up or you need my help during the webinar, feel free to drop it in the chat section. I will be keeping an eye on it throughout the session. All right, it's my pleasure to introduce Dr. Vern S. Barron. He's a research scientist with Agriculture and Agri-Food Canada, specializing in ruminant nutrition, forage utilization, and sustainable livestock production. His research focuses on improving cattle production while reducing environmental impacts, including methane emissions and forage management. And then second speaker we will have for the day is Dr. Obio Durano. He leads a livestock research at Lakeland College and is an adjunct professor at the University of Saskatchewan. Yeah, specializing in precision livestock systems, genetics, and crop livestock systems. His research focuses on practical solutions to improve beef and dairy production, efficiency, sustainability, and on-farm decisions. So first up, we have Dr. Vern. Over to you, Dr. Vern.
Okay, thank you. Can you hear me?
Yeah, we can hear you.
Okay, good. Okay, thank you for inviting me to make a presentation on the Battle River webinar series. I have a slight correction to make. Obi is the ruminant nutritionist. I am an agronomist crop physiologist, but Obi and I have worked together on these kinds of topics previously, so we're not strangers to one another. So I thought at the beginning of this talk, we should think about why we are interested in extending grazing or swath grazing practices when beef prices are so high. Because why we got interested in it in the first place was that producers were not making enough money from their cow-calf operations, and so cost cutting was very, very important. So what role does this play then when beef prices are high? So I've consulted and used information that has come from the Canadian Cow-Calf Cost of Production Network, generally chaired by Canfex and Brenna Grant. And they survey every year about 60 producers all across Canada, looking in detail at their general cost structure. And so I thought that it would be interesting to look at that and to see where these cost savings might fit in your operation. So this is the 2025 report, and each year they bring a new one out and includes data from 2025. And of course, we're in 2026, and there are some indicators of what might happen at that time. And when we talk generally about the cost that we're trying to save, usually in the past, I have talked, and many other people do, about the feed and yardage costs and the savings that we can make between using swath grazing or extended grazing like bale grazing, etc., or corn grazing with pen-fed operations. So this information is all of the data from all of the different things that those 60 producers all across Canada use. And generally, when we talk about how much it costs us to get a cow through an entire 365-day period, we're almost always talking about the cash costs, which is inputs and operations that are out-of-pocket type expenses. But yardage includes that, plus some depreciation costs, which usually comes from equipment. What we don't talk about very much at all is cost of an alternative or the opportunity cost. And the opportunity cost could be an example of an opportunity cost is what would the land you use in forage production bring back to you in revenue if you rented that land out? Or if you took land out of forage production and put it into grain and oilseed production. And so to have a very robust industry, it's necessary or is a good idea that the cow brings back enough revenue to cover all of those different cost structures. On the other hand, we've seen steer calf prices increase dramatically. And so the price of wean calves or wean steers increased from 2023 much more rapidly than cost did. And so we find ourselves in a bubble where people are making money, and that's all good. So why did that happen? Well, in part it happened because we had a decrease in our cow herd number beginning in about 2022, and that was initiated with drought and so on that occurred in that year and really expensive feed prices. People decided to get out of business. But in the 10 or 15 years before that, we had pretty much a constant cow number in Alberta and Saskatchewan, but people were not making much money at all. When I talked to Brenna Grant about how long this bubble of high prices will last, she said, well, we can look at the Canadian cow number, but it's really the American cow number that will be the tipping point, and they're not increasing. Will they increase at some point? Likely. So what does that have to do with the trend in gross revenue and costs for moderate cow-calf operations? Well, I tracked this back from Manitoba Agriculture Cost of Production spreadsheets back to 2016. And we can see that for a period of years there, almost a decade or more, the gross cost per cow, which includes opportunity costs, was greater than the gross revenue per cow. But now, after 2022, we're seeing that the revenue per cow is increasing. So it's what we do with that money and how we act from now on that would give us something that we would think about as resiliency, preparing for the future, in other words. So if we look at the projections for 2025, total cost per cow is very close to $2,000. So that's all of the costs of cash, depreciation, and opportunity costs. If we look at what we have less the cash cost, and this is usually what people look at, we would have not quite $2,000 of profit per animal. Taking depreciation into account, we're down to $1,500. Taking opportunity costs, which is much larger than many people would realize, we're down to less than $1,000. And so we kind of whittle away that big profit that we have. And this is the kind of thing that we have to look at if we're looking at stability in the future for our industry. So the projected gross revenue for 2026 is even more than that. So as people might say, don't spend it all at once. So other things that the that the benchmark showed was that, of course, the producer doesn't have much impact on the price of calf or steer, but has some impact on cost. So whether people were out of that 60 producers that were surveyed, almost all of them made the same amount of gross income per calf. It didn't really matter. But the top end of the producers that consistently made money over the years controlled expenses very well. So the key differentiator for achieving higher profitability was controlling expenses. Stronger profitability among top performing operations is driven less by increasing revenue and effective cost management. And so those top end producers were able to gradually cover cash costs, depreciation, and opportunity costs. And now in 2025, 2026, the expectation is that most of those 60 producers will be able to cover all of the costs. So be able to prepare for the future. Other interesting thing that they found was that feed type alone does not determine cost level. Rather, how feed is managed within each operation plays a critical role in influencing the total cost. So there were producers that fed corn silage, barley silage, green feed, all hay, tried to make total 365-day pastures, but that sort of thing didn't matter as much as how effective they were at managing what they chose. So farms that rely on purchase feed tend to have higher daily costs. Well, just about anybody would have concluded that, but farms that rely on pasture only risk very high costs in time of drought, heavy snow, and ice. And so not putting the eggs all in one basket, even though we're here perhaps to brag about swath grazing, not putting all your eggs in one basket is probably a good idea. Thinking about the feed costs and how they're impacted by systems which is what the cost of production reports are saying. We can use swath grazing, green feed, and silage if we look at costs, and I'm using metric units and dollars per hectare. Daily costs equal total feed costs divided by carrying capacity. So swath grazing costs about 50% of what you would in a silage operation, but most of the difference is due to the operation of equipment and costs that have to do with feeding. When we break that down on a cost per kilogram of feed, in this example that I used, which used costs from about 3 years ago, swath grazing would cost about 5 cents per kilogram and silage about 10 cents. On a cow day basis, if we assume that it takes about 12 kilograms of dry matter per day per cow to maintain the cow, then it's about 60 cents a day versus $1.20. And these are about the numbers that we're used to getting in our experiments. Quickly then, machinery and equipment costs for crop and animal production index, as indicated by the Canfax report in 2024, showed that there were dramatic increases in machinery and equipment costs, and these influence both cash and depreciation. Cash costs, if we grow the crop alone, urea fertilizer is generally increasing in cost, as is diesel fuel. And many people see this fluctuating up and down, but certainly a general increase. Depreciation and interest, the cost of a 150 horsepower utility tractor has increased by at least $100,000 over the last decade, and a skid steer tractor used in a feedlot or a livestock operation has increased about $50,000. So these all get worked into the increasing cost of depreciation. And even though we're making more cash per calf, those costs are increasing. So there is a place to use extended grazing, swath grazing or other, to maintain costs and to control costs. So what is the solution? Well, one of the things about extended grazing is it tends to be risky. So you have to deal with those sort of things, and maybe we'll learn some stuff about that. Canfax says the goal of industry at this point should be resiliency, or in other words, to be able to mitigate risk with our management practices. So over 20 to 30 years, we've been doing winter grazing systems research at Lacombe Research Center, and we'll talk a little bit about some of those. There are many different ways of swath grazing, and Obi will talk about some of the things he's been doing. And basically, whatever we're trying to do, whatever crop we're using, largely what we're trying to do is to bring the yardage cost down to zero, and the cost of feed production per kilogram as low as possible as well. So if we go back to the Manitoba agriculture production spreadsheets, these are numbers that may be used for cost of pasture, extended grazing, and winter feed that we would see over 365 days of managing a beef cow. Pasture is the lowest, of course. In their examples, they do not attribute a yardage to pasture or extended grazing. I do, but that doesn't matter too much. We see that winter feeding is the most expensive, and in our living lab farms that we work with, these numbers agree quite well. For 2025, the winter of 2025-26, we were looking at $4.62 a day, and that is a major cost to the producer. We see the number of days that we have here, and these are estimates by the Manitoba people based on the producers that use the system. So they only have 35 days of extended grazing, and we're not recommending 35 days of extended grazing. We're saying that you should be able to do more. From 2017, we've seen feed costs, the feed part of the costs, increase by 46%. We've seen yardage increase more, almost 70%, and on average of the total, we've seen that increase by 57%, and we see no reason why that isn't going to continue to increase. If we look at the best trials that we ran on swath grazing, we had very high savings, and this is an example where we used barley, triticale, corn versus pen-fed control. And at the bottom, you can see that the economic savings, where if we subtract the costs of swath grazing away from what it costs for the pen-fed, we can see that we saved more with yardage, $7,900 versus $1,600 roughly, totaling $9,566 if we grazed 100 cows for 100 days. So that kind of gives you a value. But that's one of the best trials that we had. Big labor savings, which is very important on farms these days in terms of hours and dollar value, and diesel fuel in terms of liters, which saves us some greenhouse gas emission. One of the most effective ways to reduce greenhouse gas emission. I'm searching for my cursor here. There. So in crop, the largest difference between the control and crop grazing, was equipment used dealing with harvest, and for yardage, labor, equipment, fuel, cost of feed processing, and feed and bedding delivery. So that's how we made our savings. So what is the risk of not reducing costs? Well, we could say, what is the cost of reducing costs? So in 2004 to 2012, we made those really large savings. And what we have here is 5 different trials where we had a variable amount of savings. Every trial, average over every trial, we made savings compared to a pen-fed control when we swath grazed. But in some years, particularly from 2013 through 2017, we had much less than we did in the latter 2 periods. And that was largely due to things like drought affecting the yield of the crop, lodging, mud, poor utilization. And so we'll talk a bit more about that. See here on the graph, on average, this is what our feed cost was in red and our total cost in black. So there was variation, and the variation we can see in what we call a coefficient of variation on your right-hand side. And you see that forage yield varied from about, in the lowest, which was barley in that case, 6.5 metric tons per hectare to 21.3, which is what we had for 1 year with triticale. Pasture days, we had 108 and a carrying capacity of about 855, which is about 350 cow days per acre. So those are numbers that we can kind of think about as what we should strive for and might need. But you see that carrying capacity, pasture days, and yield were lower than that. And then sometimes they were low enough to make a person question about whether he should be swath grazing or not. When we started out in the first set of experiments that we had, we thought we knew what we needed to get. So that was in red on the lower right-hand side. And you can see in the black in the middle what we actually measured. So in the first years, we were able to, the very first trials that we made, 4-year trial, we were able to double up on the carrying capacity compared to what we thought we should have. Had higher number of pasture days than we thought we should have. And our utilization, which is the amount of forage that the cattle consumed, was about 85%. We falsely thought that the cattle would eat everything that they were given. So we learned quite a bit, and these are numbers that a person who is embarking on swath grazing might think about how they fit in his system, his or her system. So the system relationships is how we compare or how we relate the crop to the animal that we're trying to feed. So we do that, first of all, in terms of economic terms to determine daily costs. So that's our benchmark. So then we achieve that by dividing what is called the carrying capacity, which is stocking rate, times the number of pasture days by the pasture cost. So we've already talked about pasture costs. We arrive at the daily feed cost by dividing by carrying capacity. Carrying capacity is heavily influenced by yield and utilization. So the word we have waste in there is related to carrying capacity. At the same time, we want to keep cow weight or cow condition constant. So we kind of know that from a buck value based on the number of days of pregnancy and what the size of the cow. So 2 big deals here. Yield, 3 big deals. Yield, waste, carrying capacity, and cost go into the daily cost. The relationship between yield and carrying capacity, and this doesn't include all of our experiments, is a direct line. And generally, utilization was in that 75-85%. Averaged over all of these treatments, including a stockpile grass experiment, we were around 600 cow days per hectare. The relationship between carrying capacity and daily cost is not quite as clear, but generally, the higher the carrying capacity, the lower the daily feed costs. And the reason why it isn't closer is because in the stockpile grass, the costs are much lower, but the land requirement is much higher. So yield is really, really important. And this is a slides of very high yielding triticale at the Lacombe Research Station and station cows grazing. And we have used swath grazing or corn grazing or both since the mid 1990s at Lacombe. So what impacts yield for swath grazing? Well, generally we have to plant later so that we later than we would for grain production so that we can swath in September or October. And the planting date is late, and that predisposes crops to drought and timing of drought. Sometimes people will plant twice to get a crop for swath grazing or other. Resistance to disease is important. We'll talk about that, what impact it has, and maybe what effect that would have on what you chose for species. And above all, the species have to be adapted to the climate and soils on your farm, and you will make that choice. I will not do that for you. So what would you choose? An example is a trial that we carried out for 3 years, and I'm showing it to you because we had several species in it. And of course, the yield potential was highest, and actual yield was highest for corn and was lowest for spring planted winter cereals and barley. Now, these had different forage quality, but we can talk about them later. When we determine from that yield at a constant utilization what the carrying capacity would be, you can see there's a range of high for corn, lowest for winter cereals, and barley. But they all didn't cost the same. Corn generally costs about double what it will cost for barley to grow for grazing. And so it turned out that there was the same cost for corn as for barley, but we had to have about 50% greater yield for that to occur. If we look at planting date, we had a study where we compared oats, barley, and triticale and published it in Agronomy Journal. We planted from early May until late June. We looked at yield and determined what the carrying capacity would be. For barley, the yield decreased with planting date, remained about the same for triticale and oats. When we calculated what the carrying capacity would be, triticale was greater than barley, and oats decreased because of quality. So there are differences in the way you get responses and when responses to planting date. And when you're planting for swath grazing or for forage, you don't tend to get the same type of response as you do for grain. So forage yield decreases, carrying capacity decreases, and costs may go up. Forage quality, utilization, and weathering. When we look at the quality for the initial quality or quality on average for a varied number of species that we had in different trials, just looking at that versus weight gain or loss, it turned out in the barley varieties that we used, we had our highest weight loss for barley and our lowest in vitro digestibility. We had the greatest response or weight gain from stockpile grass, and also over and over when we grazed corn, whether it was in the swath or not, we had minimal weight losses. One of the reasons why barley can be hit and miss is because its susceptibility to leaf diseases or scald. And this slide shows the variation in vitro digestibility in a trial that we recently completed that featured hybrid rye, fall rye, winter wheat, barley, oats, and white wheat. And barley in this case, two varieties. In this case, Canmore and Austenson had reduced yields than we expected, and also less digestibility. When years when barley leaf scald is bad, you can expect to get a 25% decrease in vitro digestibility and in yield. And that's one of the reasons why white wheats are starting to be used more for swath grazing than barley. Weathering losses, or the losses in quality that you would get over winter, tend to vary with the different species. We generally get a gradual decrease in vitro digestibility from swathing until February, March, with the small grains, so both triticale and barley decrease, but corn has been quite robust and stayed fairly high. I'm going to start talking about utilization. And poor utilization is one of the reasons why people go out of swath grazing or find ways to improve utilization and stay into it. Here's a list of things that are important. Snow and ice affect access, lodging, crops that lodge or snow on the standing crop, or varieties that are susceptible to lodging cause swathing issues and access issues. Weathering is loss of quality due to winter conditions, plant diseases we talked about, stalking rate and grazing intensity and time of grazing may be ways to alleviate some of the utilization problems we might have. And wildlife are always an issue, and some producers have found ways of mitigating that as well. The impact of utilization on cost is quite high, and many producers realize that, and they change crops for that reason. To swath graze, and even go out of swath grazing into things like corn grazing, and then from corn grazing back into silage production again. Generally, the problem is worse with low yield than high yield, because the increase in daily cow cost increases more as utilization decreases with a low yielding crop. So you're better to have your utilization in around 75% or better, and not great if you have it below 50%. Utilization impacts carrying capacity and forage quality. Residue that's left behind is not likely to have this substantial nutritive value, not usually close to what you have with a standing crop or swath. May not be palatable because it's been already grazed. May carry plant disease like ergot leaf disease and fusarium, and may be detrimental to subsequent seeding. I'm just going to show you the dynamics of how cattle will graze in a swath over a grazing period when cattle are let in, and how it might affect what you choose for a swath grazing crop. If we were choosing the ideal swath grazing crop, what would it be? So we had an experiment that we were looking for greenhouse gas emission, but we compared corn and triticale in a swath, and we let cows in an unequal number into these replications or single swaths, And over 4 consecutive days, cows grazed in the same swath. And you see here the intake or number of pounds in this case, close to 30 pounds on average were grazed out in the corn swath, but only 24 in the triticale. And with each day of grazing on the same swath, there was a more rapid decrease in the amount of grazing that occurred on the triticale than the corn. If we look at in vitro true digestibility, we see, interestingly enough, we would have thought this would have been flipped around, but the corn decreased faster in vitro digestibility over the 4 days than the triticale. If you look on the right-hand side, though, and the amount of starch that was in the swath over the 4 days decreased dramatically. The cows had cleaned out almost all of the grain or starch after 1 day grazing the corn, and at a slower rate with the triticale. So we can think about how we might use this in getting grazing done rapidly and increasing utilization. We might choose something with a higher grain content. So swaths are natural feed bunks for wildlife, and this really is also a game changer for swath grazing. But producers are finding ways to get around this. These are ducks that were grazing on some of our swath grazing fields at Lacombe. The timing and intensity of grazing is important. Producers are trying to graze at a time when the ducks or deer or whatever is not looking for an alternative source other than their natural habitat. So they may be grazing in October and not grazing with a lot of snow on the ground. The other thing is to move fields regularly because wild game tends to learn where the swaths are quite rapidly. I'm just going to give 2 or 3 more things. I know I've used up a lot of time, but how we can choose choice of varieties to reduce our risk mitigation. So in our last trial that we ran, we compared what we thought was the best barley variety and the best triticale variety based on what we learned from swath grazing versus recommended forage varieties for barley and triticale. So we found some big differences here in terms of utilization and ability to survive the different weather conditions that we had that were very rough in those particular years. The biggest difference was between Canmore barley, which we chose as being the best at the time, versus Maverick barley, which was a forage variety. We kept getting phone calls from producers that barley of this sort was leaving a lot of residue in the field. And so you see the difference between Canmore and Maverick in terms of residue amount, and this is averaged over 3 years, one of the years being really bad. The 3 years had different grazing conditions. In 2015-16, we had a lot of leaf disease that reoccurred in 16-17, but mud was the biggest problem that we had, and that really increased the amount of residue that we had to deal with. But averaged over years, cows gained significantly more weight on Canmore than Maverick and 9,4-L than Bunker, and this is one of the things that we thought might occur, but we weren't sure. Why did that happen? Well, when we start to take apart the different factors, we can see that Maverick barley and Canmore, when we compare Maverick barley and Canmore barley, we see that we had greater grain content with the Canmore barley and less with Maverick, and greater stems on the Maverick than we had with Canmore. There was less difference between the triticale varieties, but there was more grain in the 9,4-L triticale than the Bunker. In terms of leaf disease was very, very high in 2015 with the darker green and lower in 2016, but still there was leaf disease there. There was almost no leaf disease in the triticale, and people may have to use those kinds of recommendations about resistance to disease in their choice of species and varieties. What does that mean to daily feed costs? And we'll just look at the 2016-17 data. The feed cost for Maverick, which was the one with the greater issues, was about the same as the pen fed. So there was nothing to gain really by swath grazing when you used Maverick in that particular case for feed. Canmore was significantly lower. And if we look at this in the net sum thing, feed cost for Maverick was the same as the pen fed control. Canmore savings were $4,500 for 100 days and 100 cows. And this was under bad conditions. When you remember the slide we showed you, in the best case, we had $9,000 savings for 100 cows for 100 days. So the savings with Maverick were $2,000, yes. So we did make a saving, but it was all on reduced yardage, and I guess that's a good thing. One more example of what didn't work well and what did work well. We had triticale. So we had bunker triticale, same year, 2013, 2014. Very high yields, 2013, much lower in 2014. But we did different things. We had extreme snowfall, so we were only able to graze 87 days, and our carrying capacity was about half of what it was in 2014, even though the yield was much less. So the utilization wasn't all that much different, but in 2013, we only had 44% utilization, and our daily intake on both years was lower than 12 kilograms per cow per day. So, of course, we lost 11.3, we lost 11.3 kilograms per cow, which was quite lucky, but we got away with it because we took our cows off in early February. But weight loss with the 2014 cows was almost 50 kilograms per cow, which was way too much. And when we look at what was going on, we were trying to make those cows pick up the residue, and the residue had low quality. And you can see essentially the crop quality was about the same in September, but way too low for cows that were getting close to calving, and they were losing weight very badly. So that was our fault. That was our mismanagement. So the last topic I'll talk about, and I'll be very quick with it, is the question is, we think when we graze that we can reduce fertilizer. And fertilizer application is the largest cost that we have in growing a crop these days. It's probably represents 40 to 50% of the cost if we use the amount that would be recommended for silage production. When we swath graze or graze corn, usually people water or have shelter in a specific spot, and so cattle walk back and forth, and they leave excreta or manure and urine all the way across. So this lays the scene for a lot of greenhouse gas emission, and we showed that. But it also, but given a certain amount of protein or nitrogen intake, 90% of that will go back on the soil surface through urine and dung. So what does that mean in terms of the amount of fertilizer that you may or may not need? And this is totally dependent on what your farm history has been and field history has been and what you're doing. I'm not saying that this is going to occur on your farm, but this is what happened to us. So if we take our data, when we began in the measurements in 2008, we started looking at what the uptake of nitrogen was by the crop. And with high yielding crops, the uptake of nitrogen can be as high as about 200 kilograms per hectare, 200 pounds per acre. We applied 100 pounds of nitrogen because we thought, oh, well, we have these large uptakes, we have to apply fertilizer. When we took soil analysis a year later, we saw that we still had a fairly high soil nitrogen content in the 0 to 60 centimeter zone. And this continued, so we immediately lowered our fertilizer levels. And we tended to increase or decreasing them slightly. We were applying amount of fertilizer mostly for maintenance, taking care of what might be lost. But we continued on these same fields, and I'm not suggesting that this is what you should do. Probably we should be thinking about how we can use this advantage we have in swath grazing to reduce the fertilizer requirements from other crops that might follow in a rotation. So we continued to reduce the fertilizer nitrogen on these fields with different crops all the way up to about 2021. Until at that point on fields, we stopped using fertilizer. The following crop was canola, and we had record yields of canola following that crop, those crops. So the question becomes, at what point should we stop using fields for swath grazing or other and begin to rotating and harvest some of those nutrients to move away? You can see on the right-hand side, the amounts of fertilizer applied over the latter number of years that we had. In the blue was very low. The uptake in orange was high, except in 2017 when the yield was low. And you can see the amount, our calculated excreta in orange is high when we have a high utilization. And residue is dependent on utilization as well. This will only work with high yields and high utilizations, and you have to really monitor your soil nitrogen levels or your soil fertility levels. So that is my part of the talk, and I'm quite happy to turn it over to Obi, and I'll entertain questions at the appropriate time.
Perfect. By the time we do a transition to OB, if you have any questions, feel free to type it in the chat section or the Q&A, or if you're someone who doesn't like typing, they can raise their hand and I can allow them to talk. Okay, Dr. Hopi, till then, do you want to set up your, do a screen share? We
Yeah,
can't.
that would work. Yeah, we can do that. Okay. One second.
Yeah, take your time. Does anyone here have questions for Dr. Mohan? Yeah, I guess so. As
Can
of
you see
now,
it?
not. Yeah, we can see it. Yeah. If you want to start, Dr. Obi, and then we will continue the Q&A after your presentation.
Okay.
Perfect. Yeah.
That's
Okay, Dr. Obi, over to you. Yeah, you can start whenever you're ready.
okay. Yeah, so I just want to thank the organizers of this webinar for inviting us. And I will be sharing a 3-year work that we have done at Lakeland College. And here we compared monocrops and a 4-species polycrop for winter swath grazing. So yeah, let's get to it. So for my outline, I'm going to have introduce a bit. I just add a little bit more on what Dr. Byrne had mentioned. And then we will look at Swath grazing survey that we conducted in 2023. And then we'll look at the agronomics of the systems of the monocrop and the polycrop. Then we will look at beef performance in both systems. We'll look at the economics associated with each of them. Finally, we will look at soil microbiota and some take-home message for everyone. So one of the main motivations about winter Swath grazing is the ability to have enough feed materials for animals through the fall and the winter season. Now we know that the longer the winter period, the more expensive it becomes keeping animals, in a confined area. When you have winter, which is not uncommon to have up to 200 days in the prairies, especially in Alberta or even Manitoba, you have less period to grow enough materials for the whole year. So you have like 165 days in the, left off to grow enough biomass. And that means expensive, more expensive cost for the beef producer. Producers have the option of keeping the animals in a dry lot or confined area. But what that means is that you have to deliver feed to them, you have to harvest feed, and you have to take care of the animals. Those are associated with lots of costs. And even after the animals are finished consuming the feed, you have to clean the manure out of those pens. So those are additional costs. You also have the option of leaving the animals out in the field to fend for themselves, and you wouldn't have so much labor, and that way you have it as a strategy to reduce costs. So as Dr. Barron had mentioned, extended grazing is really a good strategy of keeping the animals longer in the fields. It doesn't matter if you're using bale grazing or stockpiled forage or Swath grazing or using crop residues. The goal here is to reduce costs that are associated with beef production. And when we understand that feeding constitutes up to 67% of the dry lot cost, it then means that there is an opportunity here for producers to reduce the cost of production, especially with regards to keeping the animals. So when we talk about winter Swath grazing, it is being able to seed cereal crops, cutting them, and then leaving them out there in the field for the animals to go and dig through the snow and fend for themselves. And we know that during the winter, energy requirements can increase, up to 20%. And what that means is that we need good quality feed and quantity as well to enable these animals meet their body requirements. And when we compare the Swath grazing to traditional dry lot feeding, producers can save even up to 60% of the cost and have some change in their pocket. So in terms of Swath grazing, producers have the option of using monocrops or polycrops, and each system has its advantages and disadvantages. Whether, especially on the monocrop, this is the oats, SO1 oats monocrop that we embarked on at Lakeland College. And here you would see that, yes, it's uniform. Seeding wouldn't be an issue. Applying herbicides wouldn't be an issue. Managing such system wouldn't be an issue. But when you have polycrop system, where you're planting more than one sweet species, on the same land. And the advantage is being able to supplement, meet the needs of the animals compared to a monocrop where you would have the need to supplement the animals because the same one species crop may not provide all the nutrients that the animals need. So in essence, we might need a system that where the animals can that could do more, ensuring lower costs for producers. So here you're looking at a 4-species polycrop. Here we have the oats, and we have the rape, we have the turnip, and peas as well. And this is from, there's a Swath grazing blend that is popular in the area, Vermilion area. And that actually motivated us to compare it to a traditional oat system and be able to provide information to producers. Now, when we talk about polycrops, producers have different perceptions and expectations and, something that they think the polycrop will be able to do for them. And one of them will be increased forage yield, enhanced forage quality because you have complementary species being seeded together. There is also the perception that the polycrop would have better weed suppression compared to a monocrop. You think of increased animal performance because, of course, you're expecting higher quality from the forages as well. And then one of the critical areas will have to be on soil biology. How does it really improve soil biodiversity and structure? And does it really do that? Vern had mentioned about reducing fertilizer usage. And this is one of the things that some perceive you would be able to achieve with a polycrop because you're including legumes in the mix. The other aspect is lower mineral consumption. Do animals grazing on polycrops today have a lower need for supplementary mineral or blocks? Then the other is, of course, when you have more than one species, you would expect increased costs. The other aspect is just the profits. Which one makes more money for the producer? So we're going to look at some of these perceptions and or claims, and then see what our experiences on the research had shown us. So we have that ability, we have the luxury of comparing these two systems, which producers may not be able to. And that's because they may be limited to just a single land. And by doing this, we are able to reduce the risk for producers and provide them with that objective information that they can make informed decisions. So de-risking practices and technologies, of which the winter Swath grazing is one of them. So one of the things that we did, this was in 2023, was to run an online survey. We know that Swath grazing can reduce about 40% of costs. But when you think about adoption, it was lower than 25%. But over time, it had the popularity, especially for polycrops, has started increasing. So in this survey, we wanted to understand what experiences of producers are and what are their deterrents, what are their motivations, those that continued with Swath grazing. And one of the things we learned was 43% of Swath grazers actually use polycrops. And when you look at the top species, you have oats, peas, hairy vetch, and turnips. And luckily, we have 3 out of the 4 species that we have represented here. So the oats, the peas, and the turnip. So that tells us that the adoption of polycrop is actually increasing. When you think about what is really motivating them, and this is those that Swath grazing, 94% indicated that the reduction in fuel costs was really in for them. 60% indicated reduction of labor costs. Another aspect, when we asked about deterrence, Vern had mentioned this. 24% indicated that, when animals urinate or defecate on the swath materials and they refuse to consume it, that seems like a waste to them. 22% indicated unpredictable weather conditions, deep snow, crusting on the swaths, because the animals really have to labor to consume them. 19% indicated wildlife. And here you wonder if you're feeding your animals or you're feeding deers and moose. So for some of them, it was a deterrent moving forward. And then the 4th one was 19% indicating that they weren't sure if their animals would really perform well, especially in terms of body condition. So these are the top 4 deterrents for producers. Another thing we looked at was the operators' characteristics and the relation to Swath grazing. Here I can tell you that a producer is about 3.2 times more likely to adopt Swath grazing if he or she has a spring calving already in motion. So if a producer calves March, April, he's 3.2 times more likely to adopt Swath grazing than someone that calves in January or February. Those that have stockpile operations are 2.6 times more likely to adopt Swath grazing than those that don't. A producer that has land and has control over it is 2.5 times more likely to adopt Swath grazing than someone that doesn't. When we talk about retained ownership, when producers sell off their animals at weaning, or if they are less likely. So if they can withhold their animals, maybe for backgrounding or to feedlot, such producer that has a retained ownership system is 2.3 times more likely to adopt Swath grazing than someone that doesn't. So now when we look at the agronomics of the system, this is the land area that we use. It's a 30-acre piece of land. We divided them up into 6 paddocks. And here you would see the OM means oat monocrop, PC means polycrop. And we have 3 replicates of each. The animals, or if in terms of seeding, we seeded 140 pounds for the oat monocrop. And then for the polycrop, we had 40 pounds of oats, 10 pounds of peas, and 5 pounds of a Swath grazing blend, which is the turnip and the rape. And here, looking at the seeding activities, most of our activities for over the 3 years, 2021 to 2023, we completed the first week of June. We collected samples at the soft dough stage of the oats. So we use the oats to stage, biomass sampling. At the soft dough stage and at the hard dough stage. And then we swathed 2 times. I'm going to explain why later on. And then we'll have animals weighed every 2 weeks because these were steers that we will be working with. And at the end, we had, in the first year, we got about 87 days in terms of grazing, 67 days in the second year, 2022, and 99 days in 2023. So seeding, we use the New Holland for seeding. And one important information is that throughout the 3 years, we did not add fertilizer. And that was because before we seeded in 2021, it was determined that the land had ample nutrients. And so we wanted to see, okay, which system would sustain more at the end. And so we did not apply fertilizer all through the 3 years. Here, those black dots indicate predetermined GPS spots that we went back to collect soil samples or collect biomass samples, and this we tracked over the 3 years. So 8 GPS points per paddock. I pulled this up just to show us the rainfall pattern, and this is one of the benefits of running multi-year trials because, if you do it 1 year, you might be lucky or you might be unlucky. So for the first year, we had a total of about, from 1st of June to August 19, when we swathed, we had about 87 millimeters of rain. And afterwards, we got about 41 millimeters. Now, when we were about swathing here, we working with producers as well, the suggestion was to understand if the late rains coming at this point would help the polycrops and if there was any benefit of, leaving them out or swathing, finishing, swathing all the paddocks. So we left a 30-foot strip in each of the polycrop paddocks just to see the effect of late rains, whether there will be additional biomass on them. And then if we look at the second year, from the 1st of June to August 19, we was just 203 millimeters of rain. And afterwards, we didn't get much rain. Same thing in the third year, just 5.3 millimeters of rain afterwards. So here you would see the 30-foot strip that we left just to see if there was any additional growth and whether it was beneficial, leaving it to take advantage of the rains. So during biomass sampling, we usually separated the different species to understand the contribution, special nutrient contribution of each species to the whole swath. Remember, for the polycrop, it's almost like, I call it like growing a total mixed ration. So understanding the contribution of each of the species really helps. And we did this at the soft dough and the hard dough stages. So when we compare the seeds, what we planted, to what came out, The brassicas, the rape and the turnips, about 56% of the seeds, and they generated about 24% of a dry matter yield. The oats, which constituted about 40%, gave the most, about 58% of a dry matter. And then the peas, 3% at seeding, generated about 12.2% of the yield, dry matter yield. This diagram here just shows the botanical composition, and just looking at the fraction of oats in the first year, about 45%. But when it got to the second year, because we're seeding on the same land, the same paddock every year, it jumped to 74%. And that was because we swathed at the hard dough stage when the seeds were mature. So volunteer oats in the subsequent years really increase the proportion of the oats. And here we reduced it a bit because we started applying herbicides 2 times instead of once to reduce the effect of the volunteer oats and other weeds as well. So in terms of weed pressure, you would see for the polycrop, 2.1% weed, but for the monocrop, we had about 3.3% weed. Second year, we had less than 1% weed in the monocrop, but then about 9.6% in the polycrop. And then the third year, we had about 4.4% weeds in the polycrop and about 7.6% in the monocrop. So taking all of them together and running the stats, we did not find any difference between the monocrop and the polycrop in terms of weed suppression. So that kind of showed that the expectation that the polycrop will suppress weeds more, we didn't quite see that in the data in this research for the first 3 years. Now looking at the yield, we would see that, look at the yellow line is for the monocrop. This is at a soft dough stage, and this is kilogram per hectare. During the hard dough stage, when we swathed the materials, we saw a 40% increase in biomass sampling, biomass of the yield in the oats versus the polycrop. Keep that 40% in mind because we will revisit it. And when you look at the difference in terms of leaving the rains to take hold and see if there will be any increase in biomass, there wasn't quite much of leaving the unswathed samples for the polycrop. So it wasn't of much benefit. So in terms of the contributions from different species, we'll see that the crude protein came mainly from the peas, the rape, and the turnip. Starch came from the oats, while the sugar came from, we have the peas, the rape, and the turnip. More importantly, one of the dangers of a polycrop, especially when you have brassicas in the mix, is the sulfur content. The increased sulfur content, depending on how much you have of cereals, will be diluted afterwards, and that will show us that. So in total, we have that both of them, both the monocrop and the polycrop, had approximately 67% total digestible nutrients, TDN. And that's, we think it's because, the monocrop had high starch content, while you have the soluble sugars more on the polycrop. In terms of the quality at the soft dough and the hard dough stage, crude protein was higher in the blend. Not quite higher, one might think. I should say, there was no difference between them in terms of the crude protein, but the NDF was lower for the blend at the hard dough stage, and the sulfur was also higher, but within tolerable limits for cattle compared to the oat monocrop. When we look at the Swath quality, and this is before grazing and the residues afterwards, we would see that the crude protein, although not much different between the two systems, but by the end of the grazing season, this will be in the spring, you have the oat having less crude protein than the blend. Starch, we also saw the decline, and this could be the effect of weathering as well. And the NDF really increased. And what this means is that the weathering effects, and Vern had mentioned this as well, we saw a 29% reduction in crude protein for the oat versus a 17% reduction in the polycrop. The starch saw the greatest decline in both systems, and that's 71% in the oat monocrop versus 72% in the polycrop. And a slight increase in NDF in both systems. So the other question we asked was whether we could use a polycrop to actually background weaned calves, and whether it could be something that producers could take advantage of. So again, this is the land area. Each one had between 6 to 10 weaned calves, and they grazed from the south to the north. We use electric wire cross fences. So these black lines will just indicate electric wires that we use to restrict each group of animals to their paddocks. And also moving them, we use cross fencing to move them from the south to the north. Sometimes, so we expose these animals to the elements, of course, throughout the winter. So from November to January or February that they graze. And sometimes we wouldn't be able to even run the cord to move the animals. We had our equine students help us with horses to move calves for weighing. So they had access to mineral supplement and also an energy-free water system that they could drink out of. We had we collected ultrasound body composition measures, back fat and rump fat measures. So in terms of the results, we did not see any difference in terms of body gain from these calves. So the oat monocrop at 0.7 kilogram per day, or versus the polycrop, which was 0.67, approximately 0.7 as well. So 1.5 pounds per day. They had similar weights at the end of the trial, and as well a similar ultrasound rib fat. Now, I'm showing this again just for us to understand the variation within the through the years between the two systems for the oats and the blend. And here we will see that the oat monocrop tended to have more consistent body gains compared to polycrop that was more variable. And what this kind of tells us is, for producers that may be risk averse, you might be more comfortable sticking with the oat monocrop compared to the blend that might fluctuate over years. The results, overall results, came out the same. So we had the opportunity to install rumen boluses in these animals, and we saw that the average rumen pH, and we installed the rumen boluses to understand the rumen dynamics within these animals that were placed in different forage systems. Yep, the oats had a higher rumen pH. They also had a higher rumen temperature, but the oats had a lower Swath utilization. And that's because, remember, the oats had about 40% more biomass, and they were all moved at the same time through the trial. So in terms of economics of the two systems, we see the seed prices for the oats came to about $107 per hectare, and the poly came to about $120. And for the oats, we see that at 140 pounds per acre. And then for the polycrop, you have 40 pounds per acre for oats, 10 pounds per acre for the peas, and 5 pounds per acre for the brassicas. Other things we needed to include were the other management costs. So pre-seeding, burn, harrowing, seeding, and then herbicide application, second time that we needed to apply herbicides, and swathing costs as well as land rent. Now, for producers out there, you might have a different amount that you use, but these were the ones that we collect, and you can compare yours to these and then see how much it might get close to our standard. And we got this from local rates as well as from the Alberta costs. So in terms of the perimeter, some of these we had to depreciate over time just to get actual costs. So we have the fencing, the windbreaks, and as well as the mineral that are being provided to these animals. We needed to include how much it took us to engage on different activities. So 30 minutes to set up, especially if we're going to move animals or the daily activities, health checks, moving the animals to new areas. And here we also assume that the wage was about $25.50 per hour. And for the tractor, running the tractor and build processor, it would cost about $125 per hour. So these are costs. These are costs that were similar for both systems. So we assume that they were constant between the oat monocrop and and the polycrop, whether it's the bedding or the salt and mineral equipment, which was depreciated, and also some other infrastructure depreciation, and then labor as well. So they all came up to about $1.41. And here you would see that the total cost for the monocrop, including the level of intake, it came to about $4.86 for the oat monocrop. And for the polycrop, it was about $6.09. So, and this includes a 35%, the Swath costs when we factored the dry matter produced about 35% more per head in the poly compared to the oat monocrop. So the total daily backgrounding costs that we calculated was about $1.84 for the oat monocrop compared to $1.99 in the polycrop. In terms of animal performance, remember, the gains were not different, very similar. A total gain for the 84-day period was about 60 kilograms for the oat monocrop and about 58 kilograms for the polycrop. And what this means is that when animals, well, with the animals having to start at 268 versus 266 kilograms, both systems supported body gains for the animal performance. And considering the value of the animals at the beginning and at the end of the grazing period, we see that the oat monocrop added $260 change in market value versus the polycrop, which had about $256 change in market value. And these are figures that will help us calculate the profitability of each system. Eventually, it comes to about $106 for the oat monocrop per head for the 84-day period, and compare that to the $89 per head for the polycrop. Now, when you run the stats, it says it's not different, but we know that some producers having a $17 difference might actually be motivated to take on a conventional monocropping system. Now, in terms of soil biology, which is one of the areas that, producers wonder, if they switch from monocrop to polycrop, whether they will be able to improve soil biodiversity and improve the structure of their soil. What we did was, at the beginning of the trial, before we even see that, we collected baseline soil samples in all paddocks. I mentioned all the GPS points. And we ran amplicon sequencing on the DNA that we had extracted from the soil. So baseline, we collected at 2021. And then 3 years after, and this was in the spring, after the third grazing, we went back to those GPS points to look at the soil and see if there were changes in terms of the microbiota in the soil. When we ran the alpha diversity, just looking at the changes in the different communities, we did not see any difference. whether it's in the archaea or the bacteria or the fungi. And kind of this tells us that maybe 3 years is not enough to really see some remarkable differences in soil if one decides to switch from a monoculture to a polycrop. It doesn't mean that it's not there, but maybe 3 years might just be too soon to see visible differences. And when we look at the different systems or the different indicators, both the archaea and the bacteria increased in terms of the number of communities in both systems. It increased in the old monocrop. It also increased in the polycrop. But the fungi reduced. And this could be, tillage practices. It could be, substrates. And of course, once the fungi are affected, it takes time for them to recover, unlike the bacteria and the archaea. So, but what we're saying is that the changes we are observed in both the old monocrop and the polycrop between the baseline, which is 2021, and end line, which was 2024. In terms of the archaea, we saw that the phylum Crinaceota was dominant. And this is usually the case when you have soils that are not saturated with inorganic nitrogen. So remember, we did not apply fertilizer. So 99% of the archaea in both the monocrop and the polycrop was just of this phylum. Looking at the bacteria, we saw that proteobacteria was dominant in both systems at the baseline, and depending on how you look at it, the top 5 phyla were kind of represented in both systems at the beginning. And at the end, the actinobacteria became dominant. And this is because, when you have heavy grazing, it reduces the abundance of proteobacteria and then increases the competitiveness of actinobacteria phyla. When we look at the fungal system, we saw that 3 phyla, the Ascomycota, the Martiromycota, and the Basidiomycota, constituted 97% of the communities in both systems. So there was no change. All other phyla constituted just 3% in both systems. So for example, for the Ascomycota, you have it in the oat system up to 66%, while in the polycrop, it's just about 72%. Same with the Martiromycota, 19.1% versus 14.1% at the baseline and end lines for the old monocrop and the polycrop systems. So this just, what we're trying to say is the shifts occurred similarly in both systems. So kind of wrapping this up, here we will see that polycrops actually represent a good alternative to monocrop, but could be more expensive. The body gains from the animals. So even though it had lower yield, the monocrop had 40% greater yield, the body gains on those steers were the same. That could be, some beneficial. That could be something that could be of good news for someone that intends to adopt polycrop. Now, the oats tended to have higher profits, $17. Yeah, that might be a motivator for some producers. But we did not see changes in terms of a soil microbiota between the two systems after 3 years. So what this means is that probably some things are going on, but not quite pronounced yet. So we will keep looking at this area in the next round of research on the same land. And finally, we want to say that okay, opportunities exist, whether it's increased adoption of Swath grazing as a whole or for polycrops, that there are benefits for producers. And yeah, I just want to thank the team that supported us at Lakeland College, and also collaborators. And we want to thank the funders as well for supporting the research. And yeah, I will be happy to answer any question.
Perfect. Thank you, Dr. Obi, for this amazing presentation. And I want to thank Dr. Vern again for his presentation too. And now we'll open the floor for Q&A. If you have any questions, feel free to type them in the chat or in the Q&A, or you can raise your hand if you're someone who doesn't like typing. Is there anything else you both want to add on to your presentation by the time people are typing their questions? Dr. Vern or Dr. Obi?
I think that's that. I wouldn't have anything at this point, unless
No?
if a question comes up. Yeah.
How about you, Dr. Vern? Do you want to add anything else to the presentation? You did?
No, I don't think so.
No? Okay, I guess there's no questions. I guess you guys did an amazing job with the presentation. Yeah, there's no questions at all. I guess
Well,
then we
I would make a comment then.
yeah.
Obi did a very good job of presenting a topic in which there are many, many, many questions. And so polycrop versus oat monocrop. And what we saw is not very much difference. Kind of a different crop strategy there, right, Obi?
Yes.
And so I will also say that we are seeing in the Living Labs work, we are seeing quite a lot of interest in polycrops, just as Obi mentioned. And basically the results appear to be quite similar to what Obi showed, in that it's hard to discern all the time that you're going to get huge benefits, huge monetary benefits anyway, from growing a polycrop. And because you have all those different species in that test and different climates every year, it's bound to give you variation. You will have to live with that. I think. Wouldn't you say, Obi?
Yeah, and to follow that up a bit, we have another a full should I say a follow-up to the trial. So rather than use steers, for the past 2 years we're using cow-calf pairs, and the question there is to see how both systems support cow-calf pairs. And it also gave us the opportunity to extend the window of looking at soil microbiota changes. Rather than 3 years, we'll now look at 5, 6 years. So I'm hoping that probably by the end of next season, one will be able to evaluate if there's any additional changes in terms of soil. And Uh, Also, we're looking at mineral supplement consumptions. So we have a whole lot more to uh, provide producers in terms of questions around polycrop and comparing those to monocrop.
Perfect.
So
I guess there's, yeah,
So
you can go ahead.
one more thing that I would add. So,
Mm.
there is the issue of, are we adding something more through improving soil or making soil more diverse? And it's interesting in some of the work that we have done in other areas with graduate students and so on. The biggest changes that occur in the soil microbiome occur throughout the season due to changes in climate and even time of the year.
Mm.
It also goes back to what the cost of production people were saying on a different level, of course, and cost of production, that maybe the crop here is not the most important, but the huge difference that was made was the grazing itself. And so that probably was the cause of the change. It's what Obi is saying, I think.
Mm.
The biggest cause of that change in the soil microbiome was the grazing.
Yeah, could be. Yeah.
Yeah.
And so it kind of goes back to the big things that have to do with management make more of a difference than the small things. So we have to figure out what are the big things and what are the small things. And I think what the trend of the results kind of are providing some information about that.
I agree.
Perfect. Is there anything else you want to add, Dr. Rowan?
No, but I would
Mm.
say from what I showed is that there are risks to grazing in winter, and grazing, the easiest thing to do is to graze in summer grazing. So having more than one option for your winter feeding is probably very, very important. And having an option for winter grazing of some sort will reduce your cost. It's just risky, that's all.
Perfect.
Yeah.
I guess there's no more questions, and I guess we can conclude the webinar. Thank you, Dr. Obi, and thank you, Dr. Rowan, again for taking your time today and sharing such a valuable insight. We truly appreciate your contributions. And thank you all to everyone who joined us today. That brings us to an end to this webinar. We hope you found it informative and worthwhile. If you have any feedback or suggestions for future webinars, please don't hesitate to reach out. We always are looking for ideas and that are useful for producers. Thanks again. We look forward to seeing you at our next webinar or an event. Have a great day. Thank you, guys.
Thank you.